All right, the next thing we're going to do in the unit is proofs with the identities. So it's going to be just like what we did with simplifying using identities. Now we're just going to have an equation. So we're going to have an equal sign and two things, one on either side, and we're just going to prove that the left side equals the right side. So one of the sides you're going to leave exactly the same throughout the entire process, and then you're going to simplify the other side until you can show that both sides equal each other. So in the classroom, we're going to have this poster on the wall. And you do not need to write any of this down because it's going to be up on the board. But these are some of the strategies that I've used in the past when I've done these problems to kind of make my life easier. So the first thing I always do is, before I start, is I look to see if I recognize anything. And that's kind of the substitution idea, is like, do I see like a sine over a cosine that can become a tangent? Or do I see like cos squared plus sine squared because that equals 1? Am I looking, when I look at the problem, do I see that something might happen in the future? That's what I start with. When you look at the equation, you're always going to do the most complicated side. It's easier to take something complicated and make it more simple to match up with a simple side. So that's what we're going to do. When we compare left and right for the equation, we're going to take the complicated side to simplify. You might have noticed when you were simplifying that putting things in sines and cosines makes them easier, so we're always going to try to do that if possible. Fourth, anytime you have multiple things added together on a side, we always want to put them together, especially if it's a fraction, and so you just have to remember to get a common denominator if that's the case. Fifth, don't move anything over the equal sign. That's part of the proof, is that we're trying to show that one side can exactly equal the other, and if we manipulate both sides, then we're not proving that. And then the final thing is to keep your goal in mind. So sometimes if you get stuck, you can just look at what's my end goal, what am I trying to get it to equal, and that can help you figure out how to like manipulate the problem to do what you want it to do. So we're going to go ahead and try a couple examples of these for your notes on the video. So the first example is going to be the equation secant x minus cos x equals sine x tangent x. And sometimes when you're recognizing which side is more or less complicated, that can be kind of hard to figure out. So on this one, you really could work with either side of the equation. I'm going to go ahead and focus only on the left side of the equation. So that means the right side of the equation I'm not going to touch. I'm just going to leave it there. So I'm going to start off with secant x. I know oftentimes it's good to rewrite these in terms of sines and cosines. So secant x, I'm going to rewrite this as 1 over cos x. And then I'm subtracting, and I have cos x over here. I haven't done anything to that. And the right side, you can write out sine x tan x every time, or you can write something to show it's the same. Now, the left side of the equation, remember there was one thing on the poster that said if you have, like, put the quotient as one thing, get a common denominator. And so I want to get a common denominator between these two pieces, and that common denominator I'm going to have be cos x. So I'm going to make this a fraction right now, and I'm going to multiply by cos x on the top and cos x on the bottom. So now if I was to put those things together, I have a common denominator of cos x, and on the top I have 1 minus, and since it was cos x times cos x, that would be cos squared x. And that still equals my sine x tangent x. Next, I'm going to continue to simplify the problem. So I recognize that 1 minus cos x is actually the same thing as sine squared x. And that was from my Pythagorean identity. So sine squared x over cos x. And I'm going to go ahead and write down what I want this to equal because that could be helpful. So what you'll notice is that in our final answer, we have a sine x right here, and then we have a tan x, which has a sine x in it if we were to rewrite it in terms of sine and cosine. And I can't rewrite the right side of the equation because that's what I'm trying to get it to equal. But if I keep that end goal in mind, it kind of helps me figure out how I should manipulate the left side of my equation. So what I'm going to do is I'm going to take this sine, I'm going to kind of split it in two pieces. So I'm going to write sine x times, and then I have sine x over cos x, and that equals sine x tan x. And then what you should notice is that this part right here actually equals tan x. So I have sine x tan x equals sine x tan x, and I have proved it. I am done. All right, let's do another example. This one says 1 minus sine theta over cos theta equals cos theta over 1 plus sine theta. And this next part, don't write this down, but one thing that I've done in the past is if you have 1 minus sine squared theta, that's from the Pythagorean identity. And this, if you notice, is kind of like the difference of squares. It's kind of like 1 plus sine theta and 1 minus sine theta. And I've done enough of these problems that when I see just a plain old 1 plus sine theta or a plain old 1 minus sine theta, I can usually tell that might have something to do with this, that we can bring it back there and use that Pythagorean identity. And so that's actually what I'm going to use to solve, to prove this identity this time. So I'm going to leave the right side of the equation exactly the way that it is, and on the left side of the equation, I'm going to kind of use that idea of those difference of squares to kind of simplify this. So on the top of the fraction, I'm going to multiply by 1 plus sine theta, and on the bottom of the fraction, I'm going to multiply by 1 plus sine theta. Right? So what I have on the left side of the equation right now, if I was to multiply 1 minus sine theta times 1 plus sine theta, that's the difference of squares. So I'm going to have 1 minus sine squared theta on the top, and then I have cos theta and 1 plus sine theta on the bottom. And I'll write that in blue so you guys can tell it's what we already had. And now we're just keeping that end goal in mind of the dark side, the right side. That's what I want this problem to equal. And so you can see I've already kind of matched it up a little bit. I have the 1 plus sine theta on the bottom, but I want to get rid of some of this other stuff. I want to simplify it a little bit. So if you use your Pythagorean identities, I know that this identity on the top is cos squared theta. And that first move that I did, honestly, that comes from lots and lots of practice. It just comes from doing these a lot and recognizing them. But that would definitely be a strategy, is anytime you see the 1 plus sine theta or 1 minus sine theta, thinking, is there a way I could use the difference of squares to help me out? And honestly, other than doing a lot of them, I don't know how you would maybe do a better job of recognizing that. Okay, so now what I've got is a cos on the bottom can cancel out with one of the coses on the top, and you can see I just proved it. Now I have cos theta on the top over 1 plus sine theta equals cos theta over 1 plus sine theta. So I'll go ahead and write down, I've got my final simplification here. And it's all proved. That's a check. Check. Okay, let's do one that's maybe a little bit more simple, hopefully. This one says cosecant theta multiplied by tan theta equals secant theta. So in this problem, the left side of the equation is definitely the more complicated one. And so I know that cosecant theta is really just the same thing as 1 over sine theta. And I know that tangent theta is the same thing as sine theta over cos theta. And that still equals secant theta. And now if I look at this, I can see my sign on the bottom and the sign on the top are going to cancel. And I'm just going to get 1 over cos theta equals secant theta, which we know those two things do equal each other. So secant theta equals secant theta, and I am done. And we'll do more examples in class, but I'm going to let that be it for the video so you can just let those sink in.